This is CIS126RH, Chapter 7. We're going to be talking about permissions. And with those permissions, we'll be talking about simple permissions, what they are, how to use them. We'll talk about changing ownerships. Permissions and ownerships go hand in hand. We'll talk a little bit about special permissions and then umask. Simple permissions, there are three: read, write, and execute. Read does, I'm going to cover this for files first, and then I'll cover this for directories. So for files, read does what you think it does. It allows you to read a file. Write does what you think it does. It allows you to write to a file. Execute does what you think it does. It allows you to execute a file. Now, we do call these bits. They are on or off. So we may have read permission turned on, or write permission turned on, or execute permission turned on, or we can turn those off, and we can manipulate these individually. And so the last one in particular, when it talks about files, most files are not executable, so we won't turn the execute bit on. For instance, a text document doesn't need execute. We're not going to actually execute it. A script or a program or an application does need execute. Now, in context of directories, the read, if it's turned on, is what allows us to use ls, show the contents. The write is what allows us to create objects inside the directory, like other child directories or files. The execute bit is what allows us to actually enter the directory. So if I had a directory named or whatever /pencil, if the execute bit is turned on, I can type cd/pencil and actually go into it. If it's turned off, I cannot enter it. Each one of these permissions is going to be applied to individually, once again, to three types of users. The user, which is typically the person who created the object, and it says sometimes called the user owner. In this classroom, I use that term a lot because we're trying to differentiate something here. And then there is a group. So we've already talked in a previous chapter about primary groups and supplementary groups. What typically, when an object is created, the user owner is going to be the name, is going to be the account, the user account of the person who created it, and the group owner is going to be the group, primary group of the person who created it. Now, if we want to do collaboration, we can change that group owner so that we can pick a group that have multiple people in it, and now multiple people can manipulate that object. So if it's not the user owner, and it's not what we call a group owner, or if you are not members of the specified group, you still have an account on the system, and then that would fall into others. What this leads into is a pretty simple equation. We have three types of users. Each of those three types of users have the three permissions, read, write, and execute, which mean that there are 9 total simple permissions. Seen these already in this class, didn't describe them, I alluded to them a few times. But when we do an ls space -l, it shows the permissions. Now, the permissions are actually columns 2 through 9. They are not column 1. Column 1 over here actually tells us what type of object is over here. Now, our terminal has colors these days. This is all black and white. And so if this was black and white, how do I know which may be uh, what a real server has? May only have a black and white monitor. So how do we know what these things are? This could be a directory. We don't think it is, but it could be. This could be a file. We don't think it is, but it could be. So how do we know? We look at column 1. If there's a dash here, this is a file. If there's a D here, this is a directory. And there are other types. That's for a later discussion. So what we have here is I colorized this to hopefully help make some kind of sense. We already know that this column is the user owner, and it's in green. So when we look at this user owner, the permissions that this user has on this object are these 3 green ones, and it's always 3. If a letter actually appears there, and the order of these letters is always the same, read, write, execute. If the letter appears, that means that permission is turned on. If a dash appears in the position, that means that permission is off. But it's always read, write, execute. So root here on this file has read and write permissions, and execute's turned off. So there is no execute permission. This is the group owner here. And so because it says root, we know that this is actually the primary group um, of the root user, but it could be sales. So the group owner in this golden color is the second set of permissions that are over here. And you'll notice that it's a dash, dash, dash. Well, that means that read, write, and execute are turned off. And so we do call them bits because they are bits, like binary bits. So they're on or off. So that means that the group owner, happens to be root, has no permissions on this. And remember, once again, that if you are not the user owner, you are not part of the group, you're part of others. That means, and here it is in this sort of electric blue, that dash, dash, dash on this file means others have no permission. So the only type of user, and it's very specific in this case, that can access this document, this file, is the user owner, because they're the only ones with permissions. If we look at the next example down, let's look at the other file first, all the way at the bottom. So the root user has read and write, no execute, which makes sense. myfile.txt doesn't seem like it'd be an executable file. The group owner, or this group, members of this group, have read access on this file. So if you happen to be a member of the root group, if you're Bob or Jane or, Chuck, and you happen to have this as your supplementary group, you could actually read this file. Now you won't. We'll show that. We'll demonstrate that. And then, but if you are Bob or Jane or whatever, well, you're not root. You're not part of this group. You can still read this file because you're part of others, and others does have the R. This is the same same set of permissions for initial setup KS. And then let's take a look at this real quick. You'll notice that every single directory here, desktop documents, downloads, music, have RWX, so the user owner can read, write, and execute. And once again, this is hugely important. It really, really is. Execute on a directory means that I can use CD, the CD command, to go into the directory. We do not actually execute directories. That makes no sense. And so that means that root can type CD space desktop and actually go here. It also means that members of the root group, the group owner here, have read and execute, but no write. What that means is that they can use ls. Okay, we're talking about directories. They can use ls to view the contents of capital D desktop, and they can actually CD into it. because there's an X there. It also means in this blue that if you're not the user owner, if you're not a member of the root group, so part of the group owners, you can still use ls to look at the contents because there is a read turned on here, and you can still actually type cd space desktop in order to get there. Now, with that being said, it won't happen in real life because these permissions apply to this directory. These permissions do not apply to this directory. In other words, they don't apply to the directory I'm in. What we're looking at is permissions for the child directory. These permissions are not going to allow others or even group members to come into root's home directory, which is /root. And it says here why read, write, and might seem self-explanatory. Here's a chart. Here's a chart that sort of describes what these do, the effect on directories and the effect on files. Okay. You'll notice down here, this one, where's my thingy? You'll notice down here is this. Okay. Now I'm not going to describe it here because it's, like it says, it's like 1/1000th of a time. You may or may not have an execute bit turned off on a directory. It is possible. But if you're curious, and you should be looking at these files anyway, this is actually the content file, or what we call the book. Take a look in there because it describes what happens if the execute bit on a directory is actually missing, or what we say turned off. All right, a little bit of a quiz. And so here is an output, right? An output. And we're going to say, if you are the student user, what objects in here do you have write permissions on? Okay, so the first thing I would do to solve this problem is I was like, okay, I'm going to look at this column first. I'm going to see if any of these are student, and some of them are. And then what I'm going to say is the student user does have a W here. And so therefore they can, because it says write, so therefore they have write permissions on desktop. Okay, cool. Then I'm going to say, well, here's another one. And there's a W here. So it's actually the same thing. So we have write permissions here. So I can write to this one. I can write to this one. No, here's another student. And we have write permission here. And I think my answer is wrong. In fact, I know my answer is wrong all of a sudden. Has write permissions here, which means I could write to this. Okay. The reason why I say that this is wrong, now I can go into the student column. This is irrelevant because the most, there is an order of precedence. User overrides group, overrides other. So once we found this, that the user owner has write permissions, we don't need to look at this one to see if it's true. Even if we did, we'll see the write permissions missing, but that's irrelevant because user owner permissions override group owner permissions, which override I'm sorry, I blanked out there, which override others' permissions. There is one thing, my answer was this, which is correct. And I'm looking at this, and believe it or not, there is one more for student. And it happens to be this one. So this file actually should work. And the reason why is that we have read, write, and execute for others. So student is not DevOps. And because this is DevOps, this is the primary group for this. This group has nobody in it but DevOps. But remember, if you're not the user owner, if you're not a member of the group, you fall in this others category, and there's full permissions. RWX is called full permissions, and so this should actually say downloads as well. And I never noticed that till just now. All right, let's clear this out and let's do the next one. So the next question is the sales group. So now we're looking at a group has execute access on. So because we're talking about group here, we're not even going to look at this column. It's already telling us flat out sales group. Okay. We're also not going to be concerned with others because it's telling us flat out, just flat out that it's a sales group. So I'm going to look here. And so we have to have two things to be true, that the user, that the, sorry, that the group owner column says sales. And once we find that, that this has to have an X, and it does. Sales has X here, and so documents is an answer. Sales is also here, but when we look here in the group owner column for permissions, there's no X. This is not an answer. There are no other sales, so there's your answer. The last one is other users have no access whatsoever to. Now, since we're looking at others, we don't care anything about this column. We don't care anything about this column. The only thing we're going to look at is the last three permissions bit. And by the way, I did also forget to mention that there is another column here. These are all dots. We are going to talk about that column in the next chapter. So all I'm interested in are these blue bits, and it says no access whatsoever. So no access whatsoever is dash dash dash. So all I'm looking for is dash dash dash. This is the only one, which means that this is the file, which means there you go. The sales group has read access on. So once again, we're just going to be interested in this column. We're going to say sales has read access on. So we're looking at sales. The gold is color here, second set, that's R. So documents is an answer. We have another sales here, and we say, oh, there is an R here because it says read access. So this is an answer. There are no more sales here, so that's the only answers. The next one is, come on. Assuming the DevOps user has no supplementary group membership, on which objects do they have permissions? This is from the previous chapter. Remember that when a user is created, a primary group, by default, a primary group with the same name is created for that user. Supplementary groups would be, well, any other group. This one says has no supplementary group membership. So the only thing that we're interested in is the user DevOps in this scenario, which means column 1. The only one that says DevOps happens to be this one. There are permissions here. Well, that's really bad color. Erase. Give me that color. So we have DevOps. These are the only permissions available. And so we have that. But we have to go just a wee bit further. and say DevOps. If DevOps is not the user owner and DevOps is not a member of any of these groups, DevOps still belongs to others. They do. So look, there's permissions here, 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 but not here. Because it says on which objects do they have permissions. They don't have any permissions whatsoever. It didn't specify anything. So the answer is actually DevOps has some kind of access or another to everything but anaconda-ks.cfg. Clear. And we'll pick this other blue. I think it's going to be lighter. Where can others create objects? Where can others create objects? This scenario, to create an object means it needs to be a directory. So I don't need to worry about files. I'm only going to look at directories. And because it says others, I am going to be interested in just the others permissions. And to create something requires me to have a write permission. And so if I look here, RWX on downloads. And the next one is another user kind of thing. And it says root has read, write, and execute access on which object. So this is the root user. And we're going to say read, write on which objects. And we're going to say, what we're going to say is, okay, root user. Well, the answer here is a little bit different. Because it's root. The big thing to remember here is that root is the super user. To some degree, the super user has access to everything, almost irrespective of their permissions. But if you look at this, oops, every time I use that particular cursor, I lose my mouse. So let's go back to this. Look, write permissions here, 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 and here. Root has access to everything because root is the super user. So that's the way it works. As a matter of fact, even if the permissions were turned off, root still has permissions to everything. There's another security thing called SE Linux that comes into play at that point, and that is a topic for the next the 238 class. This will make sense in a second. And no, you don't do this. That would be extraordinarily dangerous. So we're going to switch over to a terminal in just a little bit. I'm going to take a short break, and when I come back, we'll be at a terminal. Okay, so let's do a couple of things with a command called chmod, chmod. When you look at the man pages for chmod, I know it sounds funny when you say it. It says change file mode bits. What we're going to do is change permissions. I'm guessing that this definition goes back a long, long way. And you can see that we can do this symbolically, which is what it's talking about here at the top. A little bit later, I believe, yes, it does, is that we can do it numerically as well. We're going to start by doing a few examples symbolically. We'll go back to the PowerPoint because we need to. Symbolically is the easier of the two. but both have their purposes. And so you can see here the symbolic format is UGOA minus plus equals permissions. Now these permissions can be RWX, they can have a dash. UGO is user group others, what we've been talking about, like the user owner group owner others. A means all. So if I want to manipulate turning these bits on and off, um, I can do it all for all users all at once. And then there's a minus, a plus, and then an equals. Minus means I'm going to turn something off, plus means I'm going to turn it on, and then equals means to set exactly. So what we're going to do here is I've simply created an empty directory. There's nothing in here. And I'm going to touch a file, which again, touch means to create a file, an empty file, or if it already exists, um, update the timestamp. And I'm also going to go ahead and create a directory. And now when we do a long listing, we can see we have permissions and things. And even though it's not color coded, remember there are 9 permissions here. Okay. The first column tells us what this object is, whether a directory or file in this case. This last period we'll talk about in the next chapter. So for file, now that I have it highlighted, it's 3 groups of 3. So even though it's not colorized, I can go 1, 2, 3, 1, 2, 3, 1, 2, 3. So this says that the user student has read, write, and no execute. The group or members of the group student, now the only member is student, but still, it's the second set of 3, read, write, execute. And if a particular user, let's say Bob, would have read permissions, no write, no execute. The directory above it is the same 9 things. You'll notice that the only difference right now, the only difference between the directory and the file is that the directory has the X in each one of the 3 positions. That's it. That's the difference. We'll talk about how that happens, um, and how we can manipulate that at the end of this chapter. So let's change permissions. The command is chmod. And if we do this symbolically, easy thing is we're going to keep this in this whole uh, um, theme of 3s. We're going to do 3. So I'm going to say user, and we're going to manipulate the file. So I'm going to say user plus X. Now what this means here is for user owner, plus means turn on, X means execute bit. So that's how you read this. User owner, turn on, execute bit, and we give it the name of the object. When we do the listing, there's a couple of things we'll notice. Let me clear this. When we do the listing, there's a couple of things you'll notice is that here's the X. Now remember, the first 3 are for the user owner, the next 3 are for the group owner, the last 3 are for others, and it turned green. Again, if the terminal has color, what it's doing is it's letting you know that this object, this file, it knows it's a file and not a directory, has some sort of execute bit turned on. So it turned it green. Do the same thing and say, if I change this, I can do G plus X. This says, for the group owner, turn on the execute bit. And if we do a long listing, there it is. We've turned on just the execute bit. And logically enough, if we do this again for others, which is O, now you know why we call it user groups and others, UGO, and we look at it, sure enough, there's the X for others. Now I don't want the execute bit on this file. It's not a script. And so I can actually combine these. I can change this up a little bit and I can say UGO minus. And so now I'm starting to get a little bit more complicated. And what this says for user groups and others, turn off X, or the execute bit. And so I'm going to manipulate these three types of users all at once. And when we look, sure enough, the execute bit has been turned off for those three types of users. And I can mix and match those. I can do UG, UO, GO, however I want to see fit. I can do plus, minus. I could do A. I could have done A. So let's do this. A actually means all. And when we look at it, there you go. They're all turned on. So we've showed UGO, the A, the plus, the minus. How about we do, for grins and giggles, let's do the equals. So I want to combine, actually, let's do this. Let's do chmod R. Oh, I'm sorry. U equals R. So the first thing is always going to be a type of a user, UGO or A. The next thing is always going to be turn it on, turn it off, or set it exactly equal to. So I'm saying user equals R. Now, if we take a look right now for the user, which is the first three, it's RWX. What I'm saying is I want to do user equals R on the file. So just for a moment, think about what do you expect this output to be? What we did is we set user to just R. In essence, U equals R. So would have been equivalent to, let's turn these all back on. I'll show you an equivalent command. Actually, let's just do it all. Let's just do it this way. Chmod user turn on RWX. So we're going to turn on everything on the file. So we're going to get back to where we were. And so before, what we did is U equals R, set U equal to R. We could have done it this way and got the exact same effect. So now what this says is for the user, turn off, write, and execute. And now when I do a listing here, it should look exactly the same as this one. And there you go. Different way to approach the problem. These can be combined. This is going to be the last bit here. These can be combined. In other words, I can manipulate all three types of users simultaneously. And so I can say chmod, and I could say for the user, it's a file now. I want the user to be equal to read and write, comma, no space. I want the group to be able to read the file and nothing else. So I might as well just use equals. And I want others to be equal to dash. Now, if I use a single dash here, it will be dash, dash, dash. In other words, I want to turn everything off. And then I can give it the file name. And then what do we expect that this is going to look like? I'm going to suggest that it's going to look like RW dash R dash 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 dash. So RW dash R dash 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 dash. When it has dash 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 for any type of user group, or others, sometimes we say no, that means no permissions. So right now, if you're an other, you have no permission to this object whatsoever. The thing about directory, let's do the same thing for dir that we just did for file. And let's take a look at it. And what you can see here is I can do an ls of dir, and it's going to, wait a second, that's not right. Well, cd in a dir, I can't go into it. Remember that we must have execute bit in order to enter the directory. So chmod u plus x. So I don't want to manipulate the R or the W. I simply want to turn X on. And that's the nice thing about the pluses and the minuses. There's an old computer term for this. It's called bit twiddling. So I'm manipulating single bits at this point for dir. And here's the question. Can I now enter this directory? Well, let's see. Well, of course I can. And the reason, and you might be saying, well, there's no X's over here. There's no X's in this group. There's no X's in this group. Well, I'm logged on as student. The user owner of this is student. The first set of 3 bits belongs to the user owner, and there is an X there, so it allowed me in. And there was an unintended consequence a little bit earlier. If you can't descend into the directory, if you can't CD into it, you can't list it either, which is why I got caught just a little bit up here. Where was it? When I did a LL or long listing on dir, here it is, and nothing happened. That's because in order to do an LS, not only must I have the write bit turned on, but I also the execute bit is also required. So watch what happens if I do this. If I do chmod user minus W on the directory. In other words, no, read. I'm sorry. You have to have read and execute, not right. If I turn off the read bit, see, it says, hey, well, you have no permissions in order to do that. You have to be able to read the directory with LL. Here's the interesting thing. I can still go into it because the execute bit's turned on. And then once I'm in it, I still can't do it. And the reason why is because what it's actually trying to do is this. Remember, dot means present working directory, right? Well, what's the permissions on this now? Well, in order to see that, I have to look at the permissions on the parent directory, and we see that the read bit for dir is turned off. And that's even true while I'm in it, because dot means, remember, dot means the present working directory. So when I do LL, I'm trying, or LL dot, either way, I'm trying to get I'm trying to execute this command on the present working directory, and the read bit is turned off. It's like, oh, okay, I need to go back to the parent, and then I need to say, in order to fix this, I would have to do a chmod for change mode. And this is for user, turn on the read bit on dir, and now everything's going to be fixed. Okay, so that's for that. Let's pop back over to the PowerPoint. And so the PowerPoint. And this is what we just talked about, setting permissions symbolically. And this is like the whole thing. There is an options that we could have used. So there is that whole thing there. Options who, which is going to be user, group, others, or all. What action do we want to take, which is on, off, or set exactly. Now there is a fourth permission, this guy. Talk about that in just a second. So read, write, execute. This is a lowercase x, and then uppercase X is a conditional execute. I'll mention that in just a second. And then the object to which we're going to apply this. Now, what a conditional execute is, and it's almost a wall of text here, is it's primarily used when the option we use is going to be a capital R, okay, which means recursive. When we use recursive, it means that we are going to apply these permissions to the object that is specified. And if this object happens to be a directory, to all of the objects within that directory. the entire branch. In there, we are likely to have files, and we are likely to have other directories. Never forget that with very extraordinarily rare exceptions, every directory must have an execute bit, and most files will not. To be safe, we do not want to turn on the execute bit on files. As a matter of fact, we basically want to leave them alone. So that's what conditional execute means. It says when we do this recursively, as we are descending down into the child directories and grandchildren directories, for every object that we find, if it's a directory, turn on X. If it's a file, leave it alone. Basically, just leave it alone, because some files may already have the X turned on. There may already be scripts or program files. So we leave them be. That's a conditional execute. This is almost like a little Quizlet, a few slides. And so the way that this is going to work is we are going to assume right now that we have those permissions. In other words, whatever this object is has no permissions whatsoever. The user here, the first set is dash dash dash. The group set is dash dash dash. The others set is dash dash dash, and we issue this command. What will the result be? So remember that user, I kind of like this better. Remember that the user, right, is going to be this first chunk. So whatever we're doing here is not going to impact this or this. And then remember that these are always in order. Read, write, execute, read, write, execute, read, write, execute. This means to turn on, and then this R is in that position. So what we should end up with is R dash 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 dash. And there you go. So now that we have that, we issue this command. And so a little bit the same, and I'm not going to do this for all of them. We have a G, which is this is G, right? And then we have an R, and the R is always read, write, execute. So it's read, write, execute, read, write, execute, read, write, execute. So that's going to be there. And so the question is, given this and given this, I should have R dash dash, R dash dash, dash dash dash. So now we have that, and we execute this command. And what do you think we're going to get? R dash dash. Okay, so now we have that. And now we going to give like a compound thing, if you will. So remember we have a G. So the G here is the purple, which again is this part. So that's the G, not purple. What am I talking about? Orange. It's orange, Tracy. And then this for the color coding that we're using here. This is the U part. This means to turn on W. Remember, it's RWX 3 times over. RWX, RWX, RWX. So that means we are going to turn on that W, and it also means that we are going to turn on that W. So what I expect output is going to be RW dash RW dash R dash dash. Okay, so now we have that. And we issue this. And so the thing here is O is others, right? This is the O group. And plus equals on, minus equals off. And so what we're doing is, and we have an R here, so this says others, turn off R. So the result of this is that. So we have that, and now we do this. This one, not really a trick question, but you have to be very careful with this one, because A equals all. So that means that anytime you have this A here, that it's going to impact the entirety of this. Remember that equals is set exactly. I'll just put the EX period. So all set exactly X. Well, what do you think that means? Set exactly X. So we ended up turning this off, we ended up doing this. You'll never see these permissions. Um, because I have no read and write. This is completely useless set of permissions. So what? I can execute a file, can't read it, can't write to it, or I can go into a directory, but I can't read it, and I can't list it. So yeah, this is not going to work. And we also have, of course, this. So I'm setting multiple users, multiple types. Remember what goes where. So remember how to read these. If you can read these, it might help. And so if we begin with the first one, it's user set exactly to RW. In essence, I'm saying set user to RW dash. And then that comma, and I'm saying groups and others set exactly to R. So what do we get? That. And one last little example, I'm pretty sure, I think this is the last one, is this one. Again, a little tricky. You see this a lot for people who are scripting. It's a little bit of a lazy person's way. So if nothing is specified here, if this is blank, it's assumed to be A. So this is really A plus X. A meaning all, plus meaning turn on X. So we don't manipulate, we don't jimmy jack around with the existing ones. We simply turn X on. I do have another one, and here's this one. And I did point out in the specific example that you can use a dash. So this says user is going to equal to RW. So the expected result here with this is that this guy is going to get wiped out. This says G minus X. That means we're going to turn the group type, the group owner, turn off X. So we expect this one to get wiped out. This one says others equal dash, which I could put a single dash, or I could put all three dashes. And so we expect this to become dash, dash, dash. And there you go. Okay. There is a numeric way to set these. The nice thing about symbolic is I can manipulate single bits. Okay, single bits. It can get complicated looking like this when I want to manipulate multiple bits across the thing. Another way to do this is that each one of those bits has a binary value. And a binary value, I'm just going to write it on here and then erase it, is, let me get actually the pen here, is the place values are 2 to the 0, 2 to the 1, 2 to the 2, and there is this one, I'm going to write it in for the moment. We're not going to use this right now, but 2 to the 0th power is always 1. 2 to the first power is always 2. 2 to the second power is always 4. And this one's special. This one is 8, but it's special. So we're primarily going to be interested in these. Now check this out. This is R for read. This is W for write. And this is X. This is how it works. Okay. So when we talk about RWX, we're literally talking about 2 to the second, 2 to the first, 2 to the 0th power. That's why these are bits. That's why we call this bit or bit twiddling. Each letter has a value. And so where before, if I said schmod, if I said U plus R, well, R is equal to 4. Well, I could put 4. Okay. Now here's the kicker. Here's the biggie with this. I can't just specify 4. Okay. I can't just specify just the user. I have to specify, to keep it simple. I'm about to tell you a little bit of a lie, but in this particular case, to keep this simple, I must specify UGO all at the same time. So what we're going to say is, one of the easiest ways to look at this is if I want these permissions on a file. Let's say on a file, I want RW dash R dash dash R dash dash. So again, or not again, but keep in mind that the easiest way to do this is split these up into groups of 3. And then you say, okay, this first group is for users. The second one is for groups. Let me do this. And this last one is for others. So we can look up here and we can say that an R is 4, a W is 2. What we're going to do is add those values together, incidentally, just to make this complete in a way, or more complete. A dash is 0. So we're going to take these values, so it's 420, and we're going to add them together. This is a value of 6. I'm going to say 400, that's a value of 4. R dash dash 400, that's a value of 4. We have to set at minimum the entirety of all of the permissions at once. So this would actually be schmod 644 and then the name of the object. You do not bit twiddle with this. You set the entirety of the permissions all in one shot. Again, it's a wee bit of a lie, and I may explain this a little bit in the content just to be a little more complete. But for all intents and purposes, and again, this is sort of the keep it simple portion, you're going to set users, groups, and others. And this is indeed the user, the group, and the other. All right, let me clear this off. The numeric format is schmod. Give it the options, and then we're going to give it a 3-digit number. We're going to talk about a 4-digit number in a bit, but 3-digit number and then the object. And then I kept the same color coding. Green is for the user owner. Gold is for the group owner. This color blue is for others. Each permission has a value. R is 4, W is 2, X is 1, dash is 0. The easiest way to do this is to determine the complete permission set. Always do the complete permission set, and then add those values. And that's 644, and that was just dumb luck. All right. So let's take a look a little bit at some the terminal once again, and I still have these objects here. So what if I wanted to change file to rw-rw-rw-? So what we're saying here is that file is going to have read and write for every type, for user, owner, group, other, owner, and for others. And remember that r is equal to 4, w is equal to 2, x is equal to 1, and dash is equal to 0. Okay, so remembering that, we can say rw dash is 4 plus, 2 plus 0, which would be equal to a 6. Well, it turns out that I've got 3 of these. Sorry about that. We've got 3 of these sets, and they're all, and we say we want to set all of them to rw dash. One set, 4 plus 2 plus 0, is a 6, so it would be chmod, 666 on the file. And when we do an ls, lsl, we can see we have rw dash, rw dash, rw dash. Let's do this for, clear the screen. Let's do this for under the directory. So what do you think that this might be? Remembering that an R is 4, a W is 2, an X is 1, a dash is 0. Okay. So this would be, let's take a, so there you go. Remember the meme at the beginning of this section says one does not simply set 777 on their server, on their entire server. This is known as full permissions. There are no limitations. I mean, there are other security apparatus technologies involved here, but if you do this, if it's on a non Red Hat type system, if it's on maybe Ubuntu or Debian, you've just given the entire world permission to do anything to your system they want. You should never, ever use 777. You'll notice that the color of the directory turned green. This is a big no-no. So at most, not most. So directories are going to have X. That should just be, you should just be telling yourself, we need to have the execute bit for directories. And so when you're going to plan this out, you say, well, the user owner needs to be able to read and write. X is going to be just assumed. So we'll do RWX. And for the group, we say, okay, the group needs to be able to, I don't know, they need to be able to read and write as well, because we're going to do collaboration. But if I've given the user owner permissions such as RWX, and I've given the group RWX, well, I don't need anybody else in this. So it's going to be dash, dash, dash. And so this is going to translate into that dash, dash, dash is 0 plus 0 plus 0. So it's going to be chmod 770 on a directory, and then it will look like that. So we've taken away the ability of others to be able to access directory. If they need to access it, you probably want to turn off the write permissions anyway. So, where am I? Okay. I'm trying to see uh, where this should go next. Let's go back to the PowerPoint. And I have some similar things as before. So if we have this, what is the octal? And by the way, that's that's what this is. This is a numbering system. It is binary, but when we look at the non-binary digits, the 4, the 2, the 1, they're not decimal. They're actually octal. They're base 8 numbers. If you do IPv6, those are base 16 numbers. Binary is base 2. Our normal numbering system that we use every day is decimal or base 10. This is technically base 8 that we call octal. So it's going to be 420, 400, 000. We do remember we always do these in groups of 3, so we get 640, and then there's the command. So what would this one be? There you go. How about this one? That's a very common one, by the way. 755. Now, we can reverse these, of course. 644. We can reverse these and say, okay, well, what are these permissions? Keep in mind that a R is 4, a W is 2, an X is 1, a dash is 0. So with those, how do you get 6? Break them apart. How do you get 6? What combination of 4, 2, 1, and 0 gives you 6? Well, 4, 2, and you have to specify 3 of them, incidentally. So, well, 4 plus 2 is 6. Well, that means the read and write are turned on. Execute must be turned off. If the execute is turned on, it's always going to be an odd number, incidentally. So I can tell you right here, just by looking at this up here, that there are no execute bits because it's a 1. Every other digit is even. Even plus even is an even number. Even plus odd is an odd number. So it's just real basic there. So we end up with RW dash. We talked about this one. That means we break it up into the 3 separate ones. 421, 421, 421. And again, there's the 1. So these are odd numbers, which is full permissions. And then that goes back to the meme at the beginning of this. Okay, so what we're going to talk about now is ownerships. And changing the ownership, the user owner, group owner, is another task that administrators need to do, absolutely. And it's going to be done. I don't want black. It's going to be done, because when you issue a command like this, so I'm logged on as student, and we issue a command like this. Always remember that when you use sudo, you are acting as if you were root. And so I make this directory using sudo, and the result is that I end up with a directory here that has a user owner of root, has a group ownership of root, but it happens to be in student's home directory. So as it says, this is a silly example. Why would we use sudo to create a directory in student's home directory? Because now it's going to be owned by root, and guess what? Student can't access it because it's owned by root with a group ownership of root. Student would become others, and actually they could access it, but student wouldn't be able to write inside of the directory. So when something like this happens, you may need to take ownerships, or you may need to deal with these ownerships. That's done with the chown command, change owner. Once again, there are some options, and we can now you'll see that this is a weird-ish kind of arrangement of brackets and angle brackets. And what this says, actually, what this should say is I have to specify one or the other. I have to specify a username or a group name. Um, and if I specify a group name, there's going to be a colon in front of it, and then the name of the object. So let's take a look at that in real life here. And so so I have created some other users. Let me see, I need to look at my notes because I forget the names of, oh no, there they are. Okay. So, let's, on dir, I have users and groups that I've created, two users, two extra groups. The users are Bob and James, and I have sales and management. And I want to change the ownerships on file so that the sales, well, first of all, let's take a look at what I have, and as student here, I'm a member of my own group. That's my primary group. I'm a member of the wheel group. That's what gives me the ability to use sudo. And look at this, I have management as another group. So I'm going to change the group on this to management. So chown. Anytime that you specify management, you're going to put a, not management, anytime you're going to specify a group, put a colon. So management, and then the name of the object. And then when we do an LSL, we can now see that file has a user ownership of student, but now has a group ownership of uh, management. We can change. We can change the. We can obviously change the user owner. I have a username Bob. In order to do this, I'm going to have to sudo this on file, and you do not have to put a colon here. Um, and it'll change the student. And now when we look at it, Bob is now the user owner, and management is the group owner. Does student have any access to this file? The answer is yes, because student is part of the management group. So whatever permissions are available to the management group, which happen to be RW, student can do that. Student can read and write to the file. So I just wrote and then read from the file because student is part of the management group, same as Bob, as a matter of fact. Is Bob? No, Bob is not. James is. So if I switch user to James, let's try that. Oh, no, I will do this in a second. Because I created this as a subdirectory of students' home directory, James can't get into students' home directory. I'd have to create an entirely separate directory outside of the home directory structure and then give ownerships and permissions. That's how collaboration is going to be done. Right now, I'm in students' basically private home directory structure, if you will. So even though a student does not show up here at all any longer, student still has access. The student's part of management. This has permissions for management, which is read and write. So here's the write, here's the read, and it all worked. I can change both simultaneously with the command chown student. And let's say I want to change it to sales on file. And so when you want to change both at the same time, it's going to be username, and here's the colon group name. So the group name is always going to be prepended with a colon in front of it. and I have to sudo this. And when I take a look, you can see that it's student and sales. Student still has access to the file because the student user, which I am, still has RW access. It is, I think I have a note in the PowerPoints that instead of a colon, where was it? Here. Instead of a colon, you could put a dot here, but don't. And the reason why is, I'll show you in the PowerPoints, is what if I had a username of tracy.baker like I do in Australia, and I did this. Now, and for whatever reason, on this particular system, I had a group named Baker. Not likely, but let's say I did. Well, this would not change the user ownership like I would expect it to. It would work. Okay, let's see if I can say this correctly. This would work like I expected to, as long as there was no group called Baker. The system would say, "Oh, well, he actually is just changing the user to Tracy.Baker." If a group existed called Baker, that dot is a valid separator between a username and a group name. And now the system's going to go, "Oh, well, we'll change the user to Tracy, assuming that user exists, and we'll set the user to group, assuming that group exists." If both those assumptions are true, that's what's going to happen here. So don't use the dot. Because really what you're going to end up doing, or if you do have that, put a colon, go ahead and put that colon there um, um, at the end. And now it's going to know for certain that you are trying, even if Tracy exists as a user, along with Tracy.Baker as a user, and even if there is a group named Baker, this is going to tell it with no uncertainty that I want to change the user ownership on the file to Tracy.Baker. I got kind of, went down a little bit of a rabbit hole there. But basically, don't use the dot as a separator. So we'll pop back over here to this guy. We got some examples. Chosen student file. Here's the sales, Bob.management. And there is a recursive option, same thing again, apply it to the present working directory and any objects within it, and go through the entire branch of subdirectories should they exist. There is a group command. There is about trying to remember a whole mess loads of command. If chown does the job, I'm just going to use chown. But this specifically to group is specifically just to change the group. Here's the big warning and what would happen with this whole dot things. Um, so take some time to read this. Assume that there is a user named James Root, and it's James.root. There's another user named James Baker, which happens to be James. If the intention was to change the user owner object to James Root, this could be used. But the result would not be as intended. The user James would become the user owner, and the group root would become the group owner, because this would be a valid group and this would be a valid username. So just don't use dots. Okay. Just don't do that. Don't do it. So we do have special permissions. And these special permissions in this chart do certain things. We have a set UID, a set GID, and a sticky bit. And if we're going to use a symbolic method, it's going to be U plus S, G plus S, O plus T. And they also have their own octal values. and we will look at this one in particular. That's why it's in pink. And they do different things. So if the symbolic bit for the set UID is turned on, when the file is executed, this is for executable files, it will execute as the user owner. The set GID bit is one that we use very frequently. And a little bit of an aside here, in Windows, if I'm in a folder and I create a folder inside of it, a child folder, that child folder will inherit the permissions from its parent. And Linux does not do that, not by default. And so in order to turn on inheritance, the only inheritance that we can actually turn on is group inheritance. Then we must apply the set GID bit. We can do that symbolically with G plus S. So remember, before we might have G plus R, G plus RWX or dash. In this case, we would have G plus S to turn it on, or G minus S to turn it off. And you'll notice that the primary thing is on a directory. And this is really important because that also means for this to work correctly, the execute bit must also be turned on. It's a directory again. And then there is a sticky bit that has that says that you must be the user owner in order to delete the file. And so if you're not the user owner, you can't delete the file. Okay. So let's look at the terminal again. And what I've done here is I've created a directory off of root, so slash chapter 7. And the reason why I did this is because I want a location that is not within a user's home directory structure, something different, because we're going to mess with a little bit with collaboration. So right now there's nothing in it. The permissions on the permissions on chapter 7, you'll notice are a little bit different here. It's not RWX, RWX, and then there's dash, dash, dash. It's RWX, RWS, Sierra. So that S, this S here tells me that the set GID bit is turned on. And so any object that gets created inside this directory will inherit the group ownership automatically. If this were turned off, this wouldn't happen. So to set those bits is, let me clear this. So watch, let's do a chmod, and we'll do a G minus S. So this is for the set GID bit, and I'll have to do sudo because I'm student on chapter 7. And then we'll do an ls-ld on that. And what we're going to see now is that it changed to an X, and we're going to create an object. And we're going to take a look at the object, and we'll see that the user owner is student and the group owner is student. Now what we're going to do is we're going to turn this back. We're going to turn this on G plus X S, sorry. We'll take a look and see what changed here. And we'll see that there's now an S here. And we'll see that the directory has management as a group. We'll create a second file, and we'll look at that. And look what happened. I didn't, at any time, I never did a chmod command on file 2. The reason why this happened is because I turned on the set GID bit. And remember, the set GID bit says when it's turned on this directory that any object created inside this directory will inherit the group membership, group ownership. The group ownership on chapter 7. So when I was in chapter 7, I looked at chapter 7 by using dot. I could have put slash chapter 7 here. It would have worked. And it says, okay, management. And so when this got created, now the other thing you should notice is that this other one didn't change. So it's not retroactive. It will only change for those things that are new. And it also does it on directories. And you also will notice that when this directory, which is a child of chapter 7, also has that SGID bit turned on. So when I create something inside of dir, it will be owned by management. This is how collaboration works. So if I go to who's a member of management, I forgot, I left my notes over here. So James is a user of management. So let's do this. Let's say student and James are both a member of management, and I'm going to say going to put some. This text is from student, and we're going to put that in file. We're going to put that in file, and we're going to put it in file 2. And then what we're going to do is we're going to do cat file and then file 2. So I'm just using a single cat command to display both of them. So there's the text. Now I'm going to switch user to James, and I have to use James's password, and I set this up so it was Red Hat. So now I'm logged on as James. I'm going to go ahead and go to chapter 7. I'm going to do a listing. There's the same stuff, right? But check this out. There's the same stuff. So I'm going to say cat file 1 and file 2. Now here's the question. Can James read these two files? Yes. And the reason why James can read these two files is because in the first file, file 1, James is not student user, so that's irrelevant. James is not a member of the student group, so that's irrelevant. So then James becomes an other, and there is an R in the others place. Can James read file 2? James is not student. James is, however, in management, and there is an R for there. So let's see, can James write to these files? So echo, this line is from James. And we'll put it in file. Now, why am I using double greater than signs here? This was a lesson last chapter before last. I'm losing track. This is redirection. I want to take echo normally outputs to standard out, which is a terminal. I don't want it to do that. I want this text to go into that file, and I want it to append. Well, that's not going to work. Now, why doesn't this work? I said, okay, well, I'm James. I want to write to this file. So here's file. So James is not student. James is not a member of the student group. So that means James is an other. And if we look at permissions for others, there is no W. Can James do it to file 2? Absolutely. And there it is. That's because James is part of management, and management has permissions to RW. Okay. Watch what happens. This is very important. As a matter of fact, I wish I could make this better. Now, see this S? It's on a directory. what that means is technically behind the S, there is an X. And this is a lowercase s. Watch what happens. Oh, I can't do this because I can't do it this way. I need to exit James's account. It doesn't, because James has no ability to elevate privileges. James is not part of the wheel group. I have to do it with either as root or with the student account. So let's do this. Okay, so here's that S, same deal. And I'm going to say chmod, change mode, G minus X on dir. And I have to do a sudo. And now what we see here is that this is a capital S. This is bad jujus. If you have a capital X, S, if you have a capital S here, what that means is that the X that would sit behind it is turned off. Okay? It means people of the management group cannot enter this directory. So the way to fix this, the only way to fix this, is to actually turn on the execute bit that's supposed to be there. And then once we do that, there you go. Okay. Now, we've used all these symbolic methods in order to do this. There are the numeric, or what we call the octal method to do this. So, clear. So let's say that I want on dir, I want RWX. I don't want the group to have anything, and I don't want others to have anything. And because the group is basically not going to have excess, this also means that the set GID is going to be off. So one of the things that I did mention before is that there are actually, remember when we did this, like 755 and then dir, and we played around with these octal permissions, these numeric permissions, and we said that the first digit, in this case, that 7 refers to the users, that first 5 refers to the group, the next 5 refers to others. There is a fourth digit. It is assumed, and it's in this position. So 0755 is the complete set. But like any other number, if it begins with 0, that 0 has no significance, so we don't typically type it. So if we're going to do, and that first 0 is how we turn on or off these special bits. So if it is set to 0, that means that any special bit that might exist, whether it's a set GID, set UID, or sticky, we're going to turn it off. And so the rule that I wrote up there says turn the set GID bit off. So we'll put 0. Then now we address the UGO, user groups or others. So what we're going to say is that the user has RWX, has 4 plus 2 plus 1, that is 7. Then we have a bunch of dashes afterwards. So, oh, you know why it did that? It's because it was a child directory. You know why? Because rel 8 changed this. You actually have to put 2 zeros in front of this for this to work right. And I'm sorry for that. You actually have to put 00700. And it's a really weird thing that this works that way, because it's a child directory of this parent directory. I have to do a double 0 instead of just 0. Now, Let's say I said, well, that's a mistake. I want to do RWX. I do have shared um, um, group inheritance, so I need to have RWX. And because it's that, I'll go ahead and get others. Others are dash X, and set GID is on. Okay. The value on this is going to be to turn set GID bit on. Set GID is a 2, and then I have RWX for now we do the UGOs. So it's 7 for the first RWX for users, 7 for the RWX for the group, and then 5 for the R-X. And when we look at it, there you go. RWX, RWS, and then R-X. If I wanted to turn on the sticky bit, which I believe is a 1, I would have to do, if I wanted the set GID bit and the sticky bit, it would be 1 plus 3, or 1 plus 2, so it'd be 3, 775. And you'll notice that it changes all kinds of colors. If I wanted to set the set UID bit and the sticky bit and the set GID bit, the set UID is a 4, so it's 4 plus 2 plus 1 for the 3 special bits. So now I got 7775, and the colors get all kinds of, and so I thought it was going to change colors. It made a liar out of me. But you can see here, now I've got RWS. That tells me that the set UID bit is turned on. I have RWS in the group side and a group portion. And then that tells me that the set GID bit is turned on. And I have a T here in the others, which says that the sticky bit is turned on. So I'll go back to the PowerPoint here. And here they are, the 4, the 2, the 1, and what the effect of all these things do. Here is the talk, a little bit talk. Remember, 0775, we're turning them all off except for set GID on directories. It is turned off using G minus S, or interestingly, 00. They must have made some sort of change. I have, and that's fine. When setting special permissions, so that's a big note in here about all of these. And here's the walkthrough. There's the S, and actually this color is a little bit different. I'm not sure if I did it on the same computer or not. Here's the S that shows the set GID bit. There's the T that shows the sticky bit. You may have noticed that the execute bit was turned on for all users types because this is required for special permissions to work. If the X is turned off, you're going to get capital letters. This is good. Lowercase s is good. This is bad. Uppercase S is bad. This would also be true if there was an S over here. It's either lowercase or uppercase, or in the last bit over here, if it's a lowercase t or uppercase t. You should not see uppercase characters. If you do, something's wrong. So this next bit here is something called umask. So you might be wondering, when you create a directory or a file, it already has default values. And there are 3 values at play here. And this is my default. Okay. There is kernel values for a directory, and there is a kernel value for a file. And then there is a third value called a umask that is applied globally. So there's not a separate one for files and directories. And the way that it works is you take the kernel value for a directory or the kernel value for a file and you subtract the umask value to get the default value of an object that gets created. So here, as you can see, the kernel value is 0777. The umask value by default is 0002. Subtract those things, you get an octal permission of 0775, which is RWX, RWX, R-X. You'll notice that the execute bit is turned on by default, as it should be for directories. The kernel value, there we go. The kernel value for files is 0666. The same umask value applies. So when you subtract 0002 from 0666, you get 0664, and you get RW dash, RW dash, RW, R dash dash. And one of the things that you should notice here is the execute bit by default is turned off. This is the way we want it. We do not want files, when they're created, to be executable, if you will, out of the box. That's dangerous. That's really dangerous. So these are defaults. Okay. We'll pop back over here real quick. So when I create first of all, let me remove everything in here. Can I do that? Yes, I can. So if I touch a file, first of all, umask is a command by itself that will display what the umask value is. Okay. So remember that for a file, it's going to be a default of 666, 0666 minus 002. I could drop the leading zeros here, which is going to give me 664. So that's what I expect. So if I touch file and 664 equals, in order to get a 6, I need an RW. There is no 1 here, otherwise it'd be 7. I get an RW, and then a 4 is simply an R by itself. And so when we do an LS, L, that's exactly what I get. Not that. RW dash, RW dash, R dash dash. For directories, it is 777 minus 002, which gives me 775, which equals a 7 is a full set, RWX, another 7, and a 5 is 4 plus 0 plus 1. So when I create a directory, I got RWX, RWX, R-X. We can use the umask to change the value. Right now, excuse me. Right now it's 002. Let's change it to 022. 022. Double check that it changed. So for a file, it's still 666. Those are kernel values. We can't change them. Minus 022, which should give us 644. A 6 is RW with none of that. A 4 is that by itself. And a 4 is that by itself. Whoa, bad. And so create the file. Sorry. And we do a long listing. We see that file 2 indeed has that. The other thing that you notice, it's also not retroactive. File the one directly above it, did not change. The other thing about umask is that doing it this way is per user. This will not impact, if I had 10 other users logged onto the system, this is not going to impact them in the least. There is a way to do that globally, but not this way. Let's check directories, maybe 777 minus 022, which gives us 755, which gives us, for a 7, it's RWX, 4 plus 2 plus 1. A 5 is 4 plus 0 plus 1, and a 4 plus 0 plus 1. That's what we expect to get out of this. And we'll do a make dir 2, and we'll do an ls, ls-l. And we see that indeed that's what we get. So what we've basically done is we've whacked the write bit in each one of these cases by changing the umask to 022. We've turned the write bit off for the group. 022 used to be the default back in rel 6. And beginning with rel 7, they changed it to 002. I guess somebody decided that the write bit for the group should be turned on. What else do I got? Let's go back to the PowerPoint. We're almost done. And it's a command. It can be changed. This is what we just did. Yeah, we're very, very close to being finished. This shows the impact of what I just did. Those two were created with 0002 values. These were created with 0022 values. We can do all kinds of umask values. We can change it to whatever we want. Remember, it is very, 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 very important to remember that a umask value applies to files and directories equally. There's not a separate one. So in this particular scenario, if I choose a umask value of all zeros, then we're just going to create files and directories based solely on the kernel values. Here we changed it to 0077, and you can see that that 0777 minus 0077 gives us 0700, and so we basically remove all permissions from the group and for others. You might be looking at that in the second example down here and saying, well, I'm going to subtract 7 from 6, and that would give me -1. The system just changes that to 0. We can kind of permanently set these values by inserting a line into now where you see where it says tilde/.bashrc. That means that every user has their own copy of bashrc. And there's another file. Here I'm simply just echoing that into the file, making sure, if you do this, you better use double greater than. So if you use a single greater than here, you're going to wipe this file out. So you might want to vim it and actually manually add this. There you go, that's well said. Here, what it's going to talk about is that there is a way to make this global. There is a /etc/profile.d directory. .d directories exist for administrators to create their own modularized configurations. And so in this one, this is actually a script file, local-umask, and this is what it looks like. I know that we don't do scripting in here. If you might do this, you'll have these examples. But what it says is, if the user ID is greater than 199. Interestingly enough, this whole line here is actually, it's in rel 8, but this is old code. I mean, this is from rel 6 at least or before, because this actually should say 999. But just leave it be. And also this over here is bad practice. But what it says is, if the user ID, if the user who's logging in, if their user ID is greater than 999 and their group name is the same as their username, then we're going to set the umask to 777. If any of this is false, then we're going to set the umask to 0022. And this actually should say 0 now. This is old code, but this is directly from Red Hat. So there you go. Little bit of a quiz. How would you fix this bad SGID bit? And we know that it's bad because it's capital. How do we fix this? This is a boo-boo. This is a big time mistake. And the way that we fix it is we actually have to turn on the underlying X, the X that's behind it, if you will. G plus X, group plus X. Why is this set GID bit used on directories? And it is so that objects created within the directory will inherit group ownership. Which special permission will cause a program to be executed as the user owner regardless of the user who executed it? That is the set UID bit. Should this format be used to change the user owner and group owner on an object, bob.sales? And the answer is no, although it would work if Bob were a user and if sales were a group, and there were no user account named bob.sales. So yeah, just don't use it. In rel 8, what is the default mask value? What is the default kernel value for directories? What is the default kernel value for files? And it's 0002, 0777, and 0666. With that being said, we have reached the end. Again, I realize that these are long. I'm pretty sure that the next chapter, I did a cursory glance, and if what I saw is correct, the next chapter will not be this long. It's about time that we had a shorter one, I think. So I am finished.